Hi, everyone. Welcome, and thank you for attending today's IBM User Community webcast. Our topic is Into Data Science, Understanding K-means. All phone lines are in listen-only mode, and please note that the audio is being played through your computer or device. There's not a dial-in number. We will have a question and answer session towards the end of today's webcast. However, if you have a question at any time for our presenter, feel free to click into the Q&A box, and we will be able to address your questions from there. Tomorrow, we will have the replay and the slides available for download, so stay tuned for an email that you'll receive tomorrow with a link to download the materials from today. All right, with that, I would like to go ahead and introduce our speaker for today. We have joining us Jacques Roy. He's an IBM Executive IT Specialist. All right, Jacques, the floor is now yours.
Thank you. So thank you, everybody, for attending this webcast. The last time I did a webcast about a month ago, I talked about decision trees. And decision trees are what we call supervised learning, which means that we have to provide the answer so the decision tree can figure out what are the factors that decide one way or another or multiple ways. This time, I'm going to talk about K-means, which is an unsupervised learning algorithm. And machine learning is a lot about predicting, classifying, and clustering. So K-means is about the clustering part of it. So K-means was actually the term was first introduced in 1967, and the algorithm itself came out in 1957. So I always like to mention these types of things because a lot of people think that all these things are new, that it's been created recently, and everything that's been done before is not important. And so a lot of the base algorithms in the shallow learning type part and machine learning, decision trees and K-means and others, are actually things that have been around a long time. And so what K-means is, as I mentioned a minute ago, it's about clustering. And so what it is K represents the number of clusters you want to have, and means is simply internally that it basically does distances and averages to try to figure out how to get to the proper value. So let me go through an example, make it clearer. Already mentioned that. Okay, so here's a set of points that you see on a chart, and so it's two-dimension. For us, visually, we can kind of see where clusters would be, and in our case, I want to talk about 4 different clusters. So I start with 4 points. They can be any of the points that are part of the data domain, and from there, what I do is I tie the other data points to these centers that I just defined, and to the closest center to the data point. So if I do that, what I end up with is something like this, where you see that the points are all tied to the proper center because that's actually the center that's the closest to each of these specific points. And so what would happen next is that you would take the center and recenter it in the middle of the members of that group. And so what that would do is it moves the center to the proper center of this specific group. One thing you may have noticed very quickly is I'm talking about 4 centers, but we see here that we really have only 3 centers that are being used. And you see this one there is not being used at all. And so what happens is it's an iterative process. So the next time when we keep the centers the way they are, including the one that was not used. So we do a second iteration, for example, using the 4 centers. But in this case now we can see that there are some points that are closest to that lonely little point. And so what that means then is that when you group them together and recenter, now we end up with 4 centers. And so the process gets repeated multiple times like that, and we end up with, at the end, with a final result, which could look like this. A couple of things about about k-means very quickly is the fact that the centers that you use to start with may not lead to an optimal answer. So there could be reasons to try multiple starting points to get to a more appropriate solution at the end. So why do we use k-means? So one application of it is to get a meaningful intuition of the structure of the data we're dealing with. So to find out, what are the similarities between in the different records and kind of group them together. And that's useful in other types of algorithm, like alternating least square. There's kind of that concept of grouping too. And so that gives you an idea of what your data is about. And so, but there's also other reasons to use k-means, and that includes market segmentation. And you see here the clustering of customers, clustering of pricing, spending behavior, geographical cluster. I think that's the easiest to understand, geographical cluster, because, for example, if you're looking at accidents in a metropolitan area and take longitude, latitude, you're able to figure out, kind of where the groupings of accidents really are over time, and decide maybe that which section should be revisited to decide to install a stoplight, for example, things like that. There are other applications that you can use k-means for, and that includes areas of computer vision and image compression. And so with what I just mentioned here, the fact that we have market segmentation, computer vision, image compression, at least now you have an idea of where it can be applied. But let's see how it's being applied in practice. The last time I used a customer record here, and I used it to show churn analysis using a decision tree. I will use the same data. And you see here I highlighted gender, status, car owner, payment, pay method, and long distance bill type, and you see these are not numbers. So you're thinking, we look at that and we say, well, these are not numbers. How do I do k-means, which is based really on distance of points? And you see now we don't have only two dimensions; we have many dimensions. And so with that, let's move to a demo. To show you how it would be applied with code. So what you see here is a notebook in the Watson Studio environment. And so I import my data, and you see the data here looks exactly like the one I showed on the slide. And so I have my data, and I see I do a customer count here at the bottom that says I have 1,799 records in there. So a small data set just to illustrate how k-means would be used. So what we need to do is look at the columns we have, and then we need to convert the basically categorical type data. So gender, it's two choices. Status, it's three choices. Car ownership, two choices. Payment method, maybe 4 or 5 choices potentially. So you need that allows us to convert that data into numbers. There's one little thing that I want to mention there is the fact that you can convert categorical data as, for example, you look at status, so marital status, single, married, or divorced, and you could convert that to number 1, 2, 3. So depending on what you're doing, that may not be the appropriate approach. So there's another method that is available called one-hot. And what that means is instead of providing a one value that represents that category, it actually represents all the categorical choices as one vector. So if you have 3 choices, that's a vector of 3, and all the values are 0 except for the choice that is selected for that specific record. So with that, that allows us to remove the idea of distance, saying that, well, if we have back to the marital status of single, married, and divorced, you don't want to say that one thing is that divorced is larger than single, and you don't want to say that the distance between single and divorce is 2, and the distance between married and divorce is 1, and things like that. So you remove that concept from the environment. Okay, so now that in my case, just for illustration purpose, I decided to encode the labels with numbers, and so in this case, I have gender status, marital status being 1, 2, 3, etc., so on and so forth. Now that I've converted this, there's one more aspect that needs to be addressed. When we have multiple attributes to consider as part of, especially in terms in things like kmeans that really calculates distances, we're talking about distances in, I believe in this case, 15 dimensions. If we have values, for example, if you have a value of estimated income that varies from, like in this case, I have these two records, 38,000 and 29,000, I'm assuming dollars, and it could vary from 15,000 to hundreds of thousands of dollars in terms of income. That has an impact in terms of calculating distances, and that means that specific attribute could have too much weight in the decision on how things are being put together. And so what we need to do is take these values and normalize them. So basically we look at the spread of the values, and we try to move them into a spread of between -1 and 1. And so that allows them to have all the different attributes that are being considered being in the same scale. And so that's what we do here in this last section here, the section the cell number 5. Just a quick aside for people that are not familiar with this. This is a notebook, a Jupyter notebook, and that's a very popular type interface that people can use to explore their data, create models, and that allows you to add some comments in there, to add executable code and get results from executable code. Okay, so my next step, now that my data is converted all to numbers and they are all normalized to a proper scale, I can now use a kmeans algorithm. In my case here, I'm using the sklearn kmeans, and we see here when I do a kmeans, you see the kmeans at the bottom of your kmeans cluster, k equals 2, and I calculate that, I end up with some values. And the reason I did this is because I was curious to see, since my data represented churn data, if the basic 2 clusters would have any relationship with the fact that people are either will leave or will stay. And it turns out that actually it doesn't have any relationship, as I see here in the what we call a confusion matrix. So just that was a quick aside. So, but when you have a group of records, like a set of records, how do you end up finding out, okay, how many groups should I use? So there's another method there's a method that's being used that basically you calculate the kmeans for different values of k, and you see here I have a range of k between 2 and 15, and then they call that the elbow method, and you look at where the kind of the elbow occurs. This is not a perfect data set, of course, but you see that the curve goes down in terms of distortion down to, at 5, there is kind of a plateau, and then at 7, there's another plateau. So potentially 5 or 7 would be the appropriate K to use for this data set. So that shows you that when you use K-means, you need to figure out what's the most significant number of groups that you can use. So as a quick aside to all this, I decided to add the idea that you can represent graphically what K-means, your different groups, and as part of these different libraries. In this case, I'm using the PCA library, which basically allows me to reduce the number of clusters down from the 15 that I have there down to 2, and basically PCA stands for Principal Component Analysis. And so when I did that, I end up with this representation that kind of gives me a little bit of a feel of the spread of my data, because you want to look at this, and that's one way you can have an idea of how good your clustering is, the fact that all the points, different colors grouped properly. And I show here for 5 clusters, and I did it also at one point for 7 clusters. But then I thought, well, if instead of showing a representation of a 2-dimension graphic, I could go 3-dimension, maybe I'd get a better representation. And that's what I got here. You see at the bottom how my grouping is, and it still gives me the same feel that cluster number 3 seems to be a lot more spread out than several of the other clusters. There's another method that's available to reduce the number of dimensions, and it's called TSNE, for T-distributed stochastic neighbor. And so that's a different approach to do it, and you can see here that the way it represents the 2D 2D representation of the cluster is quite different from what we saw up there, and the 3D dimension, same type of thing. And so hopefully at this point that gives you an idea that how to use K-means in the sense that how to convert your data into numerical, make sure you normalize the data, and then you can even get a representation of your data. So if I keep going here, you see these different representation comparing PCA and TSNE in different dimensions. And you see that really because they use different methods, that really shows a very different representation. But once again, the cluster number 3 in both sides is a lot spread out. And same thing if I do the same thing for 7. In this case, that was cluster 2 that is quite spread out. And so you see that the grouping may not be as good as, it's not a perfect grouping, and that still give us an idea of how all the records relate to each other. So there are other ways to do K-means. In Watson Studio, for example, we have something called modeler flow that allows you to use SPSS to do K-means, and I don't have it running at the moment, but it allows you to look at the results and get a more accurate view of what the clustering did in terms of how the quality of the clustering and which are the different attributes that were the most relevant in terms of providing the clustering part. So hopefully at this point you have a better idea of what K-means is about. We talked about what you can do with K-means in a different approach in terms of segmentation and computer vision, etc. And you know how to really convert your data to be able to use the K-means algorithm. So for more information, there's a channel called Bite-Sized Data Science. It's my own channel. You can take a look at that channel and get some short videos on many subjects. I now have something like 28 videos available on different subjects. including related to data science, and you can get more information there, so please go there and subscribe. I mentioned Watson Studio, so there's also a DTE, Digital Technical Engagement Group within IBM that provides assets that gives you more information about Watson Studio. You can find that there. And the DTE sites for all the different assets available, the different products available, is the ibm.biz/DTE Live. And finally, I created a short link here, bit.ly, IBM Watson Studio registration, for people that are interested in going there and creating their own free account so they can experiment with Watson Studio. So at this point, I'd like to go over, I guess, open for Q&A. And, well, my cursor disappeared, so that's not very useful. I don't know if I can get... I would need... I need some help here because I can't read the question because, again, I lost my cursor. So I can't get to reading the question.
So, Jacques, are you able to stop the screen share and navigate back to the On24 page?
Oh yeah, I could try that. I could stop it. Oh, even stopping the screen share seems to be a challenge. It happens once in a while where my computer does that. So could you go over the questions and read them to me, and I'll try to answer? Or
sure, yeah.
I guess a couple, and then
here.
What I'd like to do though is if we could get those questions and get them to me, so I can at least post the answers when the recording will be posted on the community site. So let's go over a few questions.
So the first one we have is, can kmeans be applied to good, better, best product recommendations?
My view of this, kmeans for best product recommendation, it's to me it's a component of the solution. One of the most popular solution is called ALS, alternating least square. And so basically what they do is they alternate between grouping, let's say, customers and grouping products. And based on that, going back and forth between refining the grouping of customers and refining the grouping of products, they can then figure out, based on your history of what you, let's say, what you bought, and the people that are part of your group, which is the most likely product you'll be interested in, and you'll get recommendation. And of course, the most well-known application of that is something like Netflix movie recommendation and all the grouping that they're doing. So for recommendation, best product recommendation, you can see kmeans as basically a component of what would be used, which is the alternating least square approach, which is a subject I'd like to talk about in a future webcast. Next one.
Okay, let's see if we have any others. Next one is, will you provide I'm not sure how to pronounce this, Jupyter NB?
Oh, notebook, the Jupyter notebook. Let's see, for kmeans. I can make it available, and I guess that's with the questions there. What I will do is, as part of the Bite-Size Data Science site, I have some example code, and I use several notebooks. I don't have one on kmeans right this second. I have one at a high level. I don't think I have a notebook attached to it. So what I will do is I will make it available as part of my answers when the webcast is posted, and I will and I will post it actually in Bite-Sized Data Science, and there'll be a link to a GitHub site for that specific notebook. So yes, I will make it available.
Okay, and I think this one is a follow-up to the last question. It says, if good equals dimension A, better equals dimension B, best equals dimension C by product name. I think that was just a comment. The next one we have is, hi, will you be making the recording of the Jupyter Notebook available to participants?
So what happens with these webcasts is, you will be, since you attended the webcast, you will get an email when the recording is being posted to the, I believe the site is community.ibm.com. It's a site that has multiple subjects, but there's one about data science, and they post blog posts and dialogues through blogs and webcasts, and so that will be posted there. And as I just said, you will get an email when the webcast is posted, so you'll know where to find it.
Yep, exactly. And the link to the community is located in your resources box right now, everyone. So if you need a link back, that's where we will have the replay and the slides posted tomorrow. It looks like we have one more question in here from Thomas. In general, when is it necessary to standardize the features and machine learning algorithms?
Anything that you can feel that they're doing something based on distance. So kmeans is a great example of that. You want to normalize your data. So very often when there's multiple dimensions to deal with, you will want to normalize your data, and it's always safer to normalize it. And in fact, when you get into neural network, you have to do it, otherwise your neural network won't work appropriately. So I'd say the rule of thumb is, when in doubt, normalize.
Okay, and then it says, hi Jack, is there any guarantee with kmeans that you'll always end up with the same groups of points if you were to repeat training with the same number of centroids?
No. So basically what happens is, if you train your algorithm on the same data, starting with the same number of centers, and start with the same values, you'll end up with the same result. So what you need to do is try it with multiple starting points. So in my case, let me go back very quickly, if I can. That's a challenge. I can't, of course, because my cursor disappeared. Basically, if you remember the slide I had, I started with 4 points that were on the far left. So if instead I started with points more randomly within my population, I could end up with a different center. So it's a good practice to try a few different starting points to see if you end up with better clustering. So the answer is, if you start with different points, you could end up with different clusters. Okay.
Okay, we have how to get started with data science while planning to switch career from an Oracle Dba to data scientist, when all people ask for an experience to start with.
So that's a great question. Back to my YouTube channel, Bite-Sized Data Science. Actually, the second video that I created, I called it "Am I Obsolete?" And what happens is, with data science, what happens is the section that talks about machine learning itself is actually basically 20% of the work. 80% of the work is to find the data, exploring the data, making sure you cleanse it, and figure out if you have data missing, et cetera, so on and so forth. So as a DBA, you have that experience of being able to know how to optimize the use of data, optimize the use of cleansing your data, et cetera, so on and so on. So how would I approach it? And my channel, actually, I created it exactly for that because I've been in the industry for over 30 years. And so I've not been in data science for 30 years. And so I had to figure out how to learn these things. And I found it quite difficult because there's no good path that is shown saying, oh, learn this, learn this, learn this. And so what I try to do with my channel is if you follow the videos in order, and they're about 5-minute videos each, so it will introduce you to the different concepts. So in the early process, I talk about the foundation of what data science is about, and then I start talking about these different algorithms, not as detailed as what I did here about kmeans, because it's a 5-minute video, but it introduces the concepts, it introduces technologies, and so then you can, after a certain number of videos, I start doing examples, and I have these notebooks that I make available, and so that would be a good path to simply go through those videos, and go through the examples I have and get familiar. And again, the idea, the fact that you have to think in terms of classifying and clustering these types of things. And once you see how these algorithms work, that removes the magic out of it, and you start having a better idea, and at least you can be part of a team and contribute right away because you understand, you're able to communicate, able to communicate with the people that are more in-depth into it. And so I would take it step by step, learning about the concepts, and you can, again, in my channel, that would be the concepts I think it's 3 videos, so it would take 15 minutes for the concepts, and then start learning about the different technologies. But one thing that is important, and that's one video I want to create in the near future, is all that experience with SQL is very important, and it's important not just because you have technologies like Spark that has an SQL component to it, but because SQL has been around for a long time, is a standard way to manipulate your data, and you cannot dismiss that type of experience. I mean, this is very, very essential. So again, as an Oracle Dba, I would say you have a core of experience that is very important to any data science project. You just need to build on it, and the first step is to understand the concepts in machine learning so you can be part of the conversation and start contributing on machine learning project. And as you get deeper and try more things, then you gain more experience and you become even more valuable. So people that are coming from a data management background are essential in data science. Okay, I think we're past our time, so we'll have to stop it here, right?
Yes, that's fine. We do have a couple more questions, but if you want to wrap it up, that's fine.
No. Go ahead. I'd rather answer the questions.
Okay. One of the ones that we got here is, how detailed can we explain the results? What can we do to ensure there is no bias?
That there's no what?
Bias?
No bias. Well, the bias is it's difficult to address. What I found, and actually I'm on a project right now, and I'm learning about these types of things where it's part of your data exploration. You look at the distribution of your different attributes as part of your data set, and you can find some ideas in there that if there's always for example, in loan applications, I have that data set that says the type of employment has to be employed where if somebody is a retiree, he could not get a loan for that specific type of environment. And so you can find that out by doing some standard analysis of what was the result based on the different attributes. And then there's, if you want to push that further, there are some libraries that allow for finding out about the bias. Personally, again, I think it's a big part of data exploration to really understand your data. But you get into products like Watson OpenScale, for example, that is able to detect bias in models. But it's the data exploration, I think, that would be the first step to detect bias in your data. Next question.
Okay, the next one is, are clustering machine learning algorithms on the decline with the advent of fast and efficient deep learning?
Yeah. This is my personal view here, so take that with a grain of salt. The computer industry, like I said, I've been in it for over 30 years, and it's always chasing the new shiny thing. And you hear a lot about deep learning, and then that ties into image recognition, self-driving cars, and things like this. When you think about it, you look at recommendation engines. That's a lot more important to businesses to be able to figure out how they can build on their relationship with their customers. And so all these, what they call shallow learning algorithms, are still very valid, and that's also a lot easier to get into for most companies. So I don't see them going into decline for the next few years because so many companies are just getting into machine learning. And if you jump too fast into something you don't understand and you don't understand the results you're getting, you may lose control of your environment. I can relate that to way back in the mid-'80s when object-oriented programming or object-oriented design, all that came out. There were a lot of companies that really jumped into these things and started these huge projects, and they ended up being billion-dollar failures. You have to go gradually, and I would say if you can prove to yourself that, for example, you're able to do recommendation engines using the ALS algorithm, for example, or you're able to use decision trees to find out if your customers may leave, like in telco, for example, you lose your customers and a decision tree can provide a solution. Then once you prove yourself with that and you prove values for your company, then maybe you can say, okay, let's take it one step further and try to do a similar thing using a neural network. And yes, it's possible you'll get better results with neural networks. But the advantage of decision trees is you know exactly how the decision was made. So that depends on how the company needs to address it. Because in some cases, if you can't explain to your customer how you came up to a decision, you could expose yourself to some lawsuits. And so there's basically the bottom line is I think these shallow learning, machine learning algorithms will still be very useful for quite a while until people are able to move to more deep learning, neural network type things and prove to themselves that it does better than those proven algorithms like decision trees, kmeans, ALS, etc. Next question.
I think that's all the questions that we have that came in, Jacques. So are there any closing notes that you would like to say?
Sure. So my goal here with that Bite-Sized Data Science channel and these webcasts is to try to introduce people into machine learning. And that's really a subject that has some major benefits for any company. So I'm glad since you attended, I don't need to tell you how important it is to learn more about it, but try to get into those teams. Machine learning we say a lot at IBM, machine learning is a team sport, or data science is a team sport, and try to get on the team and try to start get some experience. And even though you may not be the person that uses the algorithms themselves, if you're exposed to how the algorithms are being used, that will improve your learning. And it's actually a lot of fun. There's a lot of satisfaction in being able to provide an answer, an insight from your data, and that's something that is essential. And hopefully, everybody that's here on the call will continue to learn more about this and start applying it, because again, the level of satisfaction of being able to get those insights is incredible. Thank you for attending.
All right. Thank you so much, everyone, for attending. Like I said earlier, we will have the replay and the slides available for download. So stay tuned for an automatic email that you'll get tomorrow. I know it's Saturday, but stay tuned for that. And then also, we will have the resources link available in your resources box. So the link to the community will take you back there and to continue asking any questions in the discussion forum. And with that, we'll go ahead and wrap it up. Thanks, everyone, and have a great weekend.